Hi guys, what's up? In this video series, we're going to give proper explanation of the topic reaction kinetics. We're also going to deal with lots and lots of practice and calculation questions as much as we can. So let's get started. So reaction kinetics. So the rate of a reaction and the mechanism by which the reaction occurs constitutes the reaction kinetics. So the rate of a reaction is determined by measuring the change in the concentration of either of the reactants or products with time. So we have here that the average rate of a reaction equals to a negative change in concentration of reactants over time, or a positive change in concentration of products over time. So to introduce this concept of the rate of a reaction, let us consider the decomposition of nitrogen dioxide, a gas that causes air pollution. So nitrogen dioxide, NO2 gas, decomposes to give nitric oxide, which is also a gas, and oxygen gas. So balancing the equation, we have 2 moles here, we have 2 moles here. So here is a sketch of how the reactant decreases with time. So here is a sketch of this reaction. So let's say we have the concentration of the reaction to here, which can be in mole per dmp. It can also be in mole per liter. So we have the time here to be in seconds. So the time is in seconds. So the concentration of the reactant decreases with time. We have NO2 to be this. And we have that the concentration of the products, NO, increases with time. Also, the concentration of the product oxygen increases with time. So at the beginning of the reaction, at time 0, the concentration of the reactant, which is NO2, is maximum. But as the time increases, the concentration decreases. But for the products, as the time increases, their concentration increases. We can therefore express the average rate of the reaction in terms of either of the reactant or product. So in terms of the reactant, the average rate of the reaction equals a change in concentration of the reactant over time. But notice that the change in the concentration of the reactant is negative here because the concentration decreases as the reaction proceeds. So it is important to work with a positive reaction rate. So a minus sign is needed in the rate expression to make the rate positive. So let's say we have this decomposition written out in this way. And let's say we have these hypothetical values for this is nitrogen dioxide. And say let's say we have hypothetical value to be 20. So this is seconds, time in seconds. So and let's say, okay, let's draw the slope. We have this, here is the slope. So let's say at this point we have 10 seconds. At this point we have 2 seconds. So let's also see on the concentration side, let's see at this point we have 5 molar, and at this point we have 10 molar. So we can calculate the average rate of the reactant NO2 using the formula here, changing concentration of the reactant against time. So we can say that the average rate of the reaction for NO2 equals the negative, you have to put the negative sign there. So since the concentration decreases with time, so this is the final and this is the initial. So this is the final time and this is the initial. So we can say that we have 5 minus 10 over 10 minus 2. So we have what? We have positive 5 here and we have 8 here. So the final answer equals positive 0.628 mole per dmq per second as well. So S minus 1. So we have to put in there. So the unit of average rate is molar per second.